On a construction site outside Tokyo, a robotic arm lifts a steel beam into place. No one guides it by hand. A few feet away, a squat orange robot walks on 4 legs, scanning the structure with lasers. Overhead, a crane moves without an operator in the cab. This isn't a concept video. This is happening right now, on real job sites, on 3 continents. For over a century, the construction industry barely changed. Concrete, steel, human hands. But in the last 10 years, something has shifted. Robots are laying brick. Robots are pouring foundations. Robots are walking job sites at night, alone, checking on the work. The question isn't whether robots will build our buildings anymore. It's how much of the job they've already taken, and what that means for the millions of people whose hands used to do this work. To understand why this shift matters, you have to understand why it took so long. Manufacturing automated decades ago. Car factories replaced welders and painters with robotic arms back in the 1980s. But construction stayed stubbornly manual, and for good reason. A factory is controlled. Flat floors, fixed lighting, the same task repeated thousands of times. A construction site is chaos by comparison. Every job is different. The ground is uneven. Weather changes hour to hour. Materials shift. Mistakes made early get buried under everything built on top of them. For a robot, that's an enormous problem. Machines are excellent at repeating a precise task in a predictable environment. Construction offered neither. But 3 things changed that equation. Cheaper sensors, dramatically better computer vision, and GPS-guided machine control accurate to the centimeter. Suddenly a machine could understand an unpredictable environment well enough to work in it safely. That opened the door, and the industry walked through it fast, driven by a problem that had nothing to do with technology at all. It couldn't find enough workers. Construction has one of the worst labor shortages of any major industry in the United States. Associated Builders and Contractors, a national trade group, has estimated the industry needs several 100,000 additional workers a year just to keep up with demand. The workforce is also aging. A large share of skilled tradespeople are approaching retirement, and fewer young workers are entering the trades to replace them. At the same time, construction remains one of the most dangerous jobs in the country. Falls, being struck by equipment, and electrocution are consistently among the leading causes of workplace fatalities tracked by the U.S. Bureau of Labor Statistics. Put those 2 pressures together, not enough workers, and the work itself being dangerous, and you get exactly the conditions that drive companies toward automation. Not because it's futuristic, because the alternative is falling further behind every single year. That's the real story behind the robots you're about to see. This isn't Silicon Valley chasing a novelty. It's an industry trying to survive its own labor math. So what does a robotic construction site actually look like today? Not in 20 years. Right now. Bricklaying, automated. A company called Construction Robotics developed a machine known as SAM, the semi-automated mason. SAM picks up bricks, applies mortar, and places them along a wall according to a pre-programmed layout, while a human worker still finishes joints and handles more complex sections. The company has stated SAM can significantly increase the number of bricks laid per day compared to manual work alone, though it's designed to work alongside a mason, not replace the trade entirely. In Australia, a company called Fast Brick Robotics, now operating as FBR, built something even more ambitious. The Hadrian X, a robotic bricklaying arm mounted on a truck-based boom that can reach across an entire home foundation and lay a full course of walls, guided by a 3D digital model of the house. FBR has demonstrated the machine printing the walls of a house in a fraction of the time traditional bricklaying takes. It's important to note this technology has been in extended development and field testing for years, a reminder that going from an impressive demo to routine daily use on ordinary job sites is its own long engineering challenge. Excavation, without a driver. A company called Built Robotics retrofits ordinary excavators, bulldozers, and skid steers with GPS, sensors, and control systems that let them dig, grade, and move earth autonomously, following a digital site plan. Their equipment has been used on real infrastructure projects, including solar farm construction, where miles of ground need to be leveled and thousands of holes drilled for panel mounts, repetitive, precise earthwork that suits autonomous machines well. Watching the work, automatically. A company called Doxel uses robots and drones equipped with cameras and LiDAR to scan a job site continuously, then uses AI to compare what's actually been built against the digital blueprint, flagging errors, tracking progress, and predicting schedule delays automatically. This doesn't replace builders. It replaces the manual, time-consuming job of walking the site and checking everything by eye, which used to fall to project managers and superintendents. Walking the site. Boston Dynamics' four-legged robot, Spot, has been deployed by major construction and engineering firms to walk job sites autonomously, capturing 360-degree photos and laser scans to document progress. Construction giant Skanska has publicly discussed using Spot on active projects. Spot doesn't build anything, but it does a job that used to require a human walking the same dangerous, unfinished terrain day after day. The fully automated site, Japan's boldest experiment. Perhaps the most advanced public example comes from Japan. Major contractor Shimizu Corporation developed what it calls Shim's Smart Site, a system where robots handle tasks like welding steel columns, installing ceiling panels, and lifting and placing materials, coordinated through a central control system, with human workers supervising rather than performing the physical labor directly. Rival firm Obayashi Corporation has developed a similar approach, known as A4CSL, deployed on large infrastructure projects including dam construction, where robots handle concrete placement and compaction with human operators overseeing remotely. These Japanese systems represent some of the closest, real-world examples of lights-out construction, sites designed around minimizing the number of workers physically present in hazardous zones. It's worth being precise here. Even these advanced systems still rely on human oversight, programming, maintenance, and supervision. No humans on site is more accurate, as far fewer humans, doing far less physical risk. And that distinction matters if we want to understand where this technology actually stands today, rather than where the headlines suggest it stands. Here's the tension at the center of this story. On one hand, these machines are being introduced in large part to fill gaps the industry can't fill with people, and to take workers out of the most dangerous parts of the job. Fewer people climbing scaffolding, fewer people operating heavy machinery in blind spots, fewer people exposed to repetitive strain injuries from decades of manual bricklaying. On the other hand, automation in every other industry has followed a familiar pattern. It starts by assisting workers, and it ends by needing fewer of them. Economists and labor researchers are genuinely divided on how construction will play out. Some argue the labor shortage is severe enough that robots will mostly fill empty positions rather than eliminate existing jobs for years to come. Others argue that as the technology matures, the number of workers needed per project will fall, even if the industry as a whole keeps growing. What seems most likely, based on how automation has unfolded in other physical industries, isn't a construction site with 0 people. It's a construction site with far fewer people, doing far more supervisory, technical, and skilled specialist work, operating robotic fleets, maintaining the machines, and handling the parts of the job robots still can't. Judgment calls in messy, unpredictable situations that no digital blueprint fully accounts for. The next frontier isn't a single smarter robot, it's coordination. Fleets of machines working together on the same site, sharing the same digital model of the building, each handling a different task in sequence, largely without a human directing every step. Combine that with 3D printed concrete structures, a technology already producing complete small buildings in the United States, Europe, and China, and you get a picture of construction that looks less like a job site and more like an assembly line stretched out across raw land. Whether that future arrives in 5 years or 25 is genuinely uncertain, and any date we gave you here would be a guess dressed up as a fact. What isn't uncertain is the direction. The tools already exist. They're already on real job sites, doing real work right now. The only question left is how much of the skyline they'll eventually build without us. If you want to understand the machines quietly reshaping how the world gets built, this is the channel for that. We cover the engineering, the mega projects, and the technology defining the next century of infrastructure with the facts checked. Not just the footage impressive. Subscribe to Engineered Future and turn on notifications so you don't miss what's built next.